right, anybody got a guess what a rational number would be? You've been dealing with them already. Anybody got a guess? Take a guess. Yeah. Not quite. So an example of rational number would be a decimal. That's the example of rational number. A decimal, which is a terminating or repeating decimal, are rational numbers. You know what I mean by TRR, terminating or repeating. Fractions are rational. Fractions, what else? Whole numbers. Negative numbers. They're all rational numbers. So we're going to be ordering these from least to greatest today. We're going to be putting them in order. We're going to be talking about positive numbers and putting them in order, and negative numbers and putting them in order. We're going to be using decimals. We're going to be using fractions. We're going to be using percents today. And if we haven't learned percents yet, that's okay. That's not a big deal. All rational. Yesterday I said something was irrational. Remember irrational? What was the irrational number? Do you remember? Yeah, it was a decimal that was like, had no rhyme or reason to it. It was like 1.25397590001. Yeah, and it went on forever. That's an irrational number. Good. Like pi, that's irrational. So these are the numbers that we're talking about today. All right, good. We're going to skip the bell ringer for now. So first we're going to talk about comparing decimals. Okay, so in your notebook, write comparing decimals. Now, a lot of people have the misconception that the longer the decimal, that's the higher one because it has more numbers in it. But that's not true. Just because a decimal has a lot of numbers in it doesn't mean it's higher than a number that has less decimal or less digits in it. Yeah? It's up to you. If you just want to show an example, it's up to you. Okay, if you want to. So let's say I'm going to compare these two numbers. I'm going to compare these two, see which one's bigger. Okay. And the easiest way to do that is to set them on top of each other, like I did here, and then start from left to right. Say, okay, I know that these two are the same, these two are the same, these two are the same, these two are not the same. Which one's bigger? The 8. This number, 2.458, is bigger than 2.457. Okay? So if you're not sure, you can put them on top of each other and start going down the line. Which one's bigger? Okay. So like here's an example that one has a bigger number or another number than the other. So I'm going to put them on top of each other. 3.74, 3.741. Now if they aren't equal, you can put a 0 and not change the other number. Okay, you're not going to change anything if you put a 0 on. So if I go down, same, 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 not the same. So this one is obviously bigger. Okay. For this one, if I look at it, 34.9 and 34.981. I can add zeros on here. Start here, same, same, same. Oh, not the same, so I know that this one's bigger. So an example of one that has more numbers that's not big would be like 3.491 and 3.52. Even though this number has more numbers, which one's actually bigger? This one, isn't it? If I look down, 3s, oh, look, this number's bigger, so this one is actually bigger. Don't think that just because it has more numbers on it makes it bigger, the bigger number. Okay? That will happen today. Somebody will do that. I'm not kidding. So make sure that if you are not sure, put them on top of each other, start going down the line, and see which one is bigger. Okay? Any questions so far? Okay. So comparing fractions. So now let's talk about comparing fractions. So we talked about comparing decimals. So let's talk about comparing fractions. So make sure you have this in your notebook. Common denominators. Denominaters are the number on the bottom, right? You guys remember that from last year? Numerators on top, denominators are on the bottom if you aren't sure. So numerator on top. Denominator you have to be able to compare two different fractions. You have to have the same denominator. That's the only way you can really compare the two. Because to me, I think of a denominator like pieces of a pie. Still math schedule. So I think of a pie, and I think of, okay, this pie has 36 pieces in it. Okay? And if there's 4 pieces out of the 36 left, or 9 pieces out of the 36 left, which one has more pie left over? Well, the 9 out of the 36. You have to have the same denominator. If you don't, you can't compare the pies, if you know what I mean. Like, the pairs have to be comparable. The pies have to be comparable to be able to look at the numerator to see what is bigger or smaller. Now, I think what I need to do with you, before I move on, I'm just going to go to the next. Okay, good. We have to talk about how to make common denominators, because sometimes this is tricky. Some people just, can I go to the next slide? Does anybody still need this yet? Okay, I'll wait a second. I'll wait. Okay, good? Anybody else? Good? Yep, you keep going. Let's talk about how to make common denominators. Let's talk about how to make common denominators. Now here, when we're just comparing, you don't have to have the lowest common denominator. Have you heard that? The lowest common denominator, it's called LCD. Have you heard of that before? Like the lowest common one? If you're just comparing, you don't have to have the lowest one. Okay, so I'm going to look at these two. I'm just looking at the bottom numbers. That's all I'm looking at. And I say, okay, what is something that 5 and 6 share? What's a multiple that 5 and 6 share? A multiple. What's something that 5 shares and 6 share? What's a number they both can go into, Jake? 30. They can both go into 30. If you don't what number they both go into, guess what you can do with these two? If you times them, that's going to give you a number they both go into. So sometimes if you are not sure, times them both. Okay? Question. Yep. So after you figure out a common denominator, I actually always do mine on the bottom. I always do mine like this. Okay? So I'm going to change these to something with 30. And when I do that, I say, okay, to myself, what did I do to take 5 to get to 30? What did I multiply by? Desi. 6. So guess what I have to do to this? Multiply by what? Yep, what I do to the bottom, I have to do to the top. Okay, so I multiply by 6 on those. Good. Now what did I do to 6 to get to 30 this time? Multiplied by what this time? 5. So guess what I got to do to the 3? Multiply by 5, so 15. Now I can compare them. Now I can look at them and say, okay, which one's bigger? Which one has more pieces of that pie left over? Obviously what? This one. This one is the bigger one. Okay. Does everybody kind of remember how to do a common denominator from last year? Or maybe something like that? Okay, so let's do this one over here. 12 and 4. What do you notice about these two? What could the common denominator be here? What could a common denominator be here, Maddie? I could keep it 12, because can 4 go into 12? Sure, I can do that. All right, so let's try that. So that means I'm going to keep this one. I'm just going to change this into a denominator of 12. So how did I get from 4 to 12? What could I multiply by? 3. So what am I going to multiply this by? 3. So that's going to be 9 twelfths, and I'm going to keep this the same. And so my answer would be 9 twelfths. Let's say you didn't see that, because sometimes people don't see that. They don't see that 4 can go into 12. What other numbers can 4 and 12 go into? Anybody have a guess? What other numbers can 4 and 12? Like, let's find another common denominator. 24. Could we use 24 as a common denominator? Sure. Some people see that easier than they see 12. 24. Okay, so let's change. So this was times 6. That's going to be times 6. Times 2, so that's going to be times 2. You're still going to get the same answer. But regardless of the denominator you use, I don't care what you use. If you see 12, use 12. If you see 24, use 24. I don't care, as long as you get the right answer. Okay? Can I give you one to do by yourself to make sure we're on the same page? Okay. 5 eighths and 3 6. 5 eighths and 3 6. 5/8 of 36. So there could be like a few different denominators in here, and that's fine. There could be a few different denominators for this one. What's the denominator you used? What's the denominator you used? Something you tried. Jake, what'd you use? Okay. Did anybody use something different? What'd you use? 48. That works too, for sure. So let's do 24. We could use 48 too. It's going to give us the same answer. So see if you got the same answer. Okay. So 24, 24. 8 times what gives me 24? 3. So 5 times 3 is 15. 6 times 4 is 24. So 3 times 4 is, wait, 3 times 4 is 12. So which one is the greater? 5/8. Or 15 out of 24. Is that what you got? Good. Good job. Any questions on how to make a common denominator? If it's a negative fraction, it works the same way. Okay, if it's a negative fraction, it works the same way. But what if I have a negative fraction? What if I do have a negative fraction? Guess what? So this is now what? What do we say? Was this 15? And this was... Okay. Now which one is greater? Now which one is bigger? Because which one is closest to 0? Yep. 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 So if you have a negative fraction, you have to think the other way. Okay, if you have a negative fraction, you have to think the other way, just like numbers up on the board. Okay, you have to think the other way. If you're not sure, just look at the top number. If you have your denominators right, look at the top number and say, okay, which one is greater now? Negative 12. Okay, so if you have a negative fraction, make sure you're thinking in the opposite way. Okay, let's compare these. Let's talk about these. Let's just do a few. Let's just do this one, and let's do this one. We're only going to do those two. Let's compare those two. We can do it together. That's fine with me. We can do it together. Let's do this first. 12 and 18 and 25 about 36. What's the denominator I could use there? Usually when it's a big number on the bottom, I can make it pretty simple. Yep. 18 can go to 36. It should be just 18. Sure. 2. It should be just 2 times. Yep. So if I go times 2, it'll be 6, 36. So just twice. So yes, I can go in. So we can use 36. 36, we said 2. This would be 24. This is 25 out of 36. Which one's bigger? Which one's bigger, McKenna? Okay, let's say I make them negative. Now which one's bigger? Yep, because that's closest to 0. Good. Nice job. Nice job. Let's do this one. What can I use for denominator on this one? You know, Haley. I can use 30. For sure I can use 30. Yeah. So I'm going to keep that. So I'm going to use this times 3 times 3. Which one's bigger? Haley? 4 and 7 out of 10. Yep. Nice job. Nice job. Way to go. How are we doing? So far, so good? Is it kind of coming back to you a little bit from 6th grade? All right, cool. Okay, so one thing you probably didn't talk about in 6th grade was comparing negative fractions and drawing a number line for them, okay? So I want you to actually do this in your notebook with me. So we're going to actually make a number line, and your homework has this today. It gives you 2 numbers, and you have to make a number line for it, and then you have to plot them on the number line. I just want you to make sure you know how to find what a negative fraction is on a number line and which one's greater. Okay, that's all they want to do with you. So these are the 2 things I'm going to put on my number line. I'm going to put this on and this on. So here's the thing about my number line. A number line doesn't always have to start at 0. I can just take a snippet of it and put it on the board. Okay, so what numbers are these really between? What are these 2 between on the number line? Not 0. Not 0. What are they between? Good try. Good try. -1 and -2. These two are between -1 and -2. Does everybody understand why they're between -1 and -2? Okay, so this is a little more than 1, and this is a little less than 2. So this is how it's going to look. -1, -2. Now, what am I going to put in between there? What am I going to put in between there? Between -1 and -2. Maddie. Okay, I can do 5 lines. Or let's just start like this. This would be 1 and 1/6. This would be 1 and 2/6. This would be -1 and 3/6. -1 and 4/6. -1 and 5/6. Why didn't I do -1 and 6/6? Haley. Because that's 2. Yep, so I can stop. Now I'm just plotting. So, okay, here it is. I'm just doing on top so you guys can see it. The other one is here. That's all. That is all. That's it. That's how you do it. That's how you do it. Let me make sure. You want to do another one like this? Let's do another one, because it'll make myself feel better. A lot of times I do things because I want to make me feel better, not you guys. Okay, let's do one that looks like this. Let's do -5, 6, and -2, 6. So let's put these two on a number line. What do these two fall between this time? What do they fall between? -1 and 0. So 0 and -1. Does anybody understand why I'm putting my number line like this? Because it matches exactly like up there. Okay. So now what am I going to put in here? Now what am I going to put in here? Yep, -1/6. Good. Yes. -3/6. -4/6. -5/6. Then I plot my points right there, and the ends. Okay. So I think there's 1, 2. What are you going to? Only to 10. I suppose we could do that. So there's only 2 of those on there. That's okay. I still want you to know how to do them. All right, any questions on how to make a number line with 2 numbers? Figure out what they're between, and then go from there. Okay. All right, so last thing I have is percent to decimals. Okay, so on your notebook, write percent to decimals. How do we change percents to decimals? Very simple. It's very simple. There's one rule. One rule. Move. You're going to need this in your notebook too. Decimal. 2 spaces to left. Okay, so move your decimal 2 spaces to the left, and you automatically make it a decimal then, even if it's a percent. So let's practice some of these. So if I have 45%, where's my decimal at 45%? Where's my decimal at 45%? Where's my decimal? Take a guess. Where's my decimal? Maddie? Not in front of the floor. Good try. What if I would take my percent off where would my decimal be? What if I would not have that sign there? What would it be? In a whole number, yeah? Okay, behind the 5. Anytime you have a whole number and you don't know where the decimal is, it's right there. They just don't put it there. Okay? So anytime you have a whole number, the decimal's in the back. So if I'm going to move this 2 spaces to the left, this is how it goes. 1, 2. That's my new space. 45% is 0.45 in a decimal. Okay? So 23%, where's my decimal on 23%? Where does it start, Kara? Yeah, behind 3. So if I'm going to move it 2 spaces, 1, 2, 23% is really 2.23 in a decimal. So the next one's kind of lucky. It already has a decimal in it for us. So I'm just going to start where that decimal is, move it 2 spaces, and this would be 0.345 in a decimal. That's all. That's it. Pretty simple, right? It's pretty simple. If I have a decimal like this, I'm just going to quick do this. Let's say I have 3%. What would this be in a decimal? Yeah? Yep, If you are moving a space, you don't have anywhere to move it, you can just put it to 0. Anybody have questions on this? Okay, I have one more slide. One more. What they're going to do on your homework today is they're going to ask you to order these from least to greatest. Okay, so what do we have in there? We have a percent, we have a decimal, and we have fractions. What do you think would be the easiest way to order these from least to greatest? Because off the top of your head, do you know which ones are greater than the other? No. Okay, so how can we order these from least to greatest? What can we do to them? Yeah? I would change them all to decimals. Change all to decimals. And you know how to do all of that already. Oh my gosh, I can't spell. Change all the decimals. I'm going to erase that so I can have room. Change to decimals. Because you guys know how to order those. So we have 23%, 0.21, 1/4, and 1/5. Let's change all of these to decimals. What's 23% in a decimal? Maddie? Okay. This one's already in decimal form. That's cool. What about this? 1/4. You guys should know this one off the top of your head. Think of quarters, yeah? 25, which would be 0.25, yep. And then 1/5, you maybe have this one figured out too in your head, Maddie. 0.2 or 0.20, right? If you don't know how to do that, what can you do though? Like if you don't know that off the top of your head, what can you do to figure out what that is? Do you remember from yesterday? Yep, 1 divided by 5. There you go, 0.2. Perfect. So if you don't know how to do some of those in your head, do them out like we did yesterday. So then we have 0.20. All right, so now let's order from least to greatest. But they want you to write out them this way in least to greatest, not this way. So what's the lowest one up there? What's the smallest one up there? Kira? 0.20, which is in turn 1/5. That's my lowest one. What's my next one, Maddie? 0.21. We're just keeping them in the same form. So we got this one taken care of. We got this one taken care of. What's my next smallest? Yes. 23%. Good. And my next one is 1/4. That's how you would order those from least to greatest. That's how you'd order them from least to greatest. And I think in your homework it's only just like 3 of them, not 4. Okay. Do you want another example of this? No? Are you sure? Nobody wants another example? You're going to be okay, even if they're negatives? If they're negatives, let's say they were all negatives. Now which one's the smallest? 1/4. Okay, so if it's negatives, because there's one in here that's negatives, you have to be on your game. Think, okay, which one's closer to 0? That's going to be the greatest. Which one is farther away? That's the least. So you got to be careful. Especially if they're negatives, because I know there's one in there, I can see it from here. Any questions? Any questions? Okay. For what percent? Yep. Yes, it was. Oh, I didn't do it on there. I just said if they were all negatives, now what would they be? So if they were all negatives, it would look like this. That's how it looks if they're all negatives. Okay. Quick. If I have this, how do you change those denominators? Same way. You just leave the whole number in the front. You do it the same way. Just so you know. There's something like that in 2. So you could just do 5, 8, 5 and 2/8, and then you can